What's up, Simstuck? Coordinate proofs today. 720p, not even 480. Edited some stuff. So, I think we already did number 1 in class, but I'll go over number 2, 3, and 4, just as many as I basically can. So, for number 2, it tells us that the points P, which is located at 0, 1, A, located at 2, -2, R, 3, 1, and K, 1, 4, are the vertices of a quadrilateral. So let's try and graph that now. So P at 0, 1, A at 2, -2, R at 3, 1, and K at 1, 2, 3, 4. This is supposed to be the graph. Hold on. 0, 1. Alright, this is 0, 1. Silly. Anyways, so let's just connect that with a line here, 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 and here. And what are these points? This is P, A, R, K, and this is a quadrilateral. Looks like a parallelogram, but we don't know that for sure yet, so we have to prove that it is a parallelogram by showing the opposite sides are congruent. So, opposite sides are congruent. Okay, well, if we want to find the opposite sides are congruent, then we need to know that this is congruent to this side, and also this side is congruent to that side. And to do that, we need to find the distance of all of these sides and confirm that. Can we find the distance of these? Of course, we know the points of each one, and we know our formulas. Most importantly, the distance formula, which goes something like x1 minus x2 squared plus y1 minus y2 squared, extend that, equals the distance of any 2 points, right? So we could try that. So let's try getting the distance of each of these segments, and hopefully this won't take too long. So first let's do the pair PK and AR. So let's do PK and AR first. So for PK we have P is 0, 1, so P x1 is 0, K's x value is 1, so it's 0 minus 1 squared, plus P's y value is 1 minus K's y value, which is 4 squared, and this goes to 1 squared plus 3 squared, and that just is 1 plus 9, which is square root of 10. Okay, square root of 10, and that equals the distance of PK. So that is this right here. This orange is that. And maybe we want to find AR now in purple right here. So let's do that in purple. AR, x value of A minus the x value of R squared plus the y value of A minus the y value of R squared. That's also 1 plus 9, and that is 10, and that equals AR. Well, based on our results, we both got the square root of 10, so we do know that these two sides are indeed congruent. So we have one pair that's congruent so far. We need to find the other pair. So I'm just going to erase this because it takes a bit of space. And so we have PK and AR checked off, so that's good. Now let's try, I'm going to use the color blue for this. The distance of KR. I'm going to do KR, and PA. So for KR we have x value of K minus x value of R squared plus y value of K minus y value of R squared. So we have 4 plus 9, and that's 13. So this is square root of 13. If you want, this is square root of 10, this is square root of 10, if you want to know. And now we have to do PA, so let's do PA. Let's just go black for this one. And PA, x value of P minus x value of A squared plus y value of P minus the y value of A. And it's 1 plus 2 because it's 1 minus negative 2. And that's just 1 plus 2, right? So this is again 4 plus 9. And that's 13. So again, both these are 13, so this is indeed congruent to this, and now we have two pairs of congruent opposite sides. So, and by definition, if we have a quadrilateral with two pairs of opposite sides, then we know that that quadrilateral has to be a parallelogram. So our solution here is therefore, which is like this pyramid of 3 dots, PARK is a parallelogram because it has two pairs. Oh, actually, why write two pairs when I could just say opposite sides? Both pairs of opposite sides congruent. And that is our proof, and I just went over why because of the distance formula. So that is that. Let's just do one more. So here for number 3 we have the points Q, which is -1, -2, U, which is -2, -5, A, which is -5, -7, very negative, and the -4, -4. Very, very third quadrant like, I should say. This should be interesting. So let's graph these in blue. This is Q. I think this is U. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. This is A. And this is D. And let's connect these with a line to the best of my ability. And that's quad Q, U, A, D. And we need to find that it's a parallelogram by showing the diagonals bisect one another. So interesting here. If the diagonals bisect one another, it means that they have the same midpoint, right? Because the midpoint divides a line segment into two equal sides, so it bisects, right? A midpoint is kind of like a bisector. So if both diagonals have the same midpoint, then they just bisect each other, right? So here we just need to find the midpoint of DU and QA. So we need to, wrong tool, find the midpoint of QA and DU. And if they're the same, then we know that quad is a parallelogram. So quick, what's the midpoint formula? x1 plus x2 over 2, comma, y1 minus y2 over 2. The average of the x values, comma, average of the y values. So let's do QA first. So QA would be -1 plus -5 over 2, comma, -2 plus -7 over 2, close parentheses. That's -1 minus 5, -6 over 2, and this is going to be -9 over 2. We could simplify this more to be a coordinate of -3 and -4.5, but I'm just going to leave this like this. So we know that we're looking for a midpoint of -6 over 2 and -9 over 2. I'm just going to leave it like this because it's a bit less work. So DA is done, QA is done, check. Now let's do DU. So that's going to be -4 minus 2 over 2 and -4 minus 5 over 2. Right? Just follow the formula. And again we get -6 over 2, comma, -9 over 2. And we see that these are the same, they're equal. So same midpoint. So what can we conclude if they're the same midpoint? So our hypothesis was correct. They did have the same midpoint, so that must mean that they bisect each other because a midpoint bisects a line segment. Therefore, quad is a parallelogram because its diagonals bisect each other by having the same midpoint. Abbreviate that. So that is basically it. Number 4 is pretty easy. To give you a hint, it is a slope proof. So the slope formula, really quick, is just y1 minus y2 over x1 minus x2, I think. So just find the slope of all 4 segments and then find that they're parallel, and then the 2 adjacent sides of the rectangle are perpendicular, so it has 1 right angle, which then in turn makes it 4 right angles. And you'll see when you do number 4. So that's the end of this video. Thanks for watching.